Maresy dotes and dozy dote.
And then
You don't want a
me.
brainworm?
Yeah, exactly. There, that should be me. Whew. All right. Yeah, I knew something had to go wrong, obviously. So apparently, for some reason, when you reconfigure your, I guess when you don't use OBS for a couple of months, it just busts in random ways.
No, OBS, if you don't use it over a weekend,
Yeah,
bust.
yeah, exactly. Yeah, I know. But I've figured out how to keep our audio levels about the same. I
Good.
think and we sorted that out like on the last episode of last season. So
Yeah.
yeah. Well, then you will never know what we were talking about. Never know.
You'll
Maybe
never know.
someone
And it
is
was
going to,
interesting
yes,
too.
someone's going to lip read and figure it out that we were talking about computer screens and the tyranny of too many screens. All right. Hey, how's it going?
Temperatures are finally livable again. The room is filled with dogs. The blind is down. Clearly, it must be time to start season 14.
Season 14.
Season
Wow.
14.
We had no summer here. We had normally there are a couple of weeks a year when I start to get price quotes on heat pumps and air conditioners because it's just so awful and you're tied to the fan and you head outside as quickly as you can. This summer, my lawn never turned brown. It's just green the entire way through. It was cool. And we never had any days above 30 when usually we'll have a bunch of days above 30. I don't know what that is. I don't know, 45,000 in Fahrenheit. And there was almost no nights when I was like, oh God, it's so hot in our house. And I just wanted, we need to hide. No, it was cool, the entire thing. And it wasn't terrible weather, although it did rain a bit. It was just mild all summer long. It was perfect. Perfect summer, except,
We weren't as mild as you, but normally we're putting in our air conditioning units by mid-June.
Yeah.
And this year we made it all the way to the 4th of July, which is like what I'm used to from when I lived in Boston. And I've already pulled the air conditioning units back out. And this led me to have an epiphany I wish I had never had about climate change.
Mm-hmm.
Now, we talk about how the average temperature of the planet is going to go up about 1 degree, and that doesn't really seem like a lot. Now, the problem isn't that, that 1 degree is a massive problem, not going to lie. But day to day, the issue isn't so much that 1 degree of average, but the redistribution of heat across the planet. So this mild summer that you and I had and so many other people had got transformed into an, oh my God, it's hot.
Yeah.
Summer for folks
Europe.
up in Alaska, in Scandinavia, in Northern Europe.
Yeah.
Germany got those 40-degree days that you did not get.
Yeah. Yeah, it's amazing how awful it was in Europe apparently over the summer. Just horrendously hot.
So those mild days that any of you have, remember the way averages work. If your temperature goes down, somebody else's temperature goes up.
Yep.
And I wish I didn't understand this, but now we can all wish we didn't understand this together.
I half wrote my introduction, I realized.
So I'm going to let you all know now. Earlier today, I did some audio recording. We've actually launched a new daily podcast over on CosmoQuest. It's a quick roundup of news. So basically get the 30-second version from me, then click on over to Universe Today and look for a longer story written out. And while I was recording it, I did the standard 10 seconds of audio noise and then looked at my waveform when I was all over. And there's this tree frog in our waveform.
Yeah. Was it a real tree frog?
It was a real tree frog. So there's a tree frog that is like right outside my window somewhere. It seems to be done for the day to come back later on. So if there is chirping, it's a tree frog.
Yeah.
And And as always, my lighting is kind of not perfect. Sorry about that, folks.
I'm going to say hi to a bunch of people. I'm going to say hi to Amanda Saito Cautino, Andy Cowley, Andy Gravity Nonsense, Bill K, Brooke Mulugeta, Chad Weber, Dustin King, George Lancaster, Gordon Dewis, Guido Bibra, Harry M, John Victor, Jordan Young, Kyle Carmichael, Larry Beckham, Michael Bayer, Michael Meyer, Nancy Graziano, Noel Ruppenthal, Omega Centauri, Obert Over Luna, Paranor, Pyro Nitro, Rich Wilson, Rich 901, Richard, Side MT, Susie Murph, Therion, Thomas Traniker, Track Clap, Trickle Cap, Trina Johnson, Umu, Uncle Bill Druin, William Bacon, and Zap Van Zap Van. Hey, everybody. For those of you who are new, you just, when you show up in the first couple of minutes, just say hi to everybody, and then I will say your name. Say my name. And Chad. Astro YYZ. So if I didn't read your name, Quad Limit, it's because it dumps the names of the participants every 5 minutes or so, I think. And so I've only got, there's like this window of 5 minutes where you've both got to say hello, and I've got to check the names and then be able to read them out. So that's why it all comes together. Anything else interesting? So what happened? I climbed a bunch of mountains.
Oh, wow.
Yeah.
That's cool.
Yeah, we climbed. We did 2 bigger hikes this summer. One to this place called Landslide Lake, and the other one was Mount Albert Edward, which is one of the tallest mountains on Vancouver Island. But it's like way up above the tree line into the rock and the snow. But it's just this beautiful ramp. So it's like the one mountain on the island that anyone can hike. So that was us. And sort of dialing in our ultralight pack. We took the dog, kind of ruined her.
How did you ruin the dog?
Well, she, it's a beatdown. It's a beatdown on anybody. And so we've been taking the dog out on all of our hikes, and she just, the next day she was super stiff and really sore with her paws. You could see we were walking along this trail. We got, it was nice, soft dirt.
Boots.
I know we've got boots. No, we've got boots, but she hates them. So if it's really rough, we'll put boots on her. But we came up to this. The trail's really soft and dirt, and then we come up to the part where it's like crushed, like gravelly river rock, but really sharp. And so the dog just stops and just sighs, just looks forward and goes like, nope. And so I picked her up and carried her through that section because she's pretty light. But and in fact she had an ingrown hair on one of her paws, so that was kind of bothering her, and we thought it was an injury that she'd gotten on the hike, but it turns out she sort of had grown it herself, and so we had surgery just a couple of days ago to have that removed. It's like the 3rd time we've had surgery on this dog's feet. So that was what we did. It was just gorgeous. I mean, I love the parks and outdoor spaces that we have here on the island.
That is amazing. That is so much more pleasant sounding than what I did, which was to lead the CosmoQuest community through marking 10 million objects on the surface of Bennu. I hate rocks. Yeah. Still not done. We are now waiting on confirmation of the quality of the data before we do the final sample site selection. Oh my God, we marked rocks. We're expecting to be done by July 10th. And the mission team didn't tell me this, but when they took one look at how bad that asteroid was, they were like, oh yeah, the citizen scientists are going to take at least a year to get through that. And me, I was like, oh my God, we've got to finish. Oh my God, we have to finish.
Yeah. You were pretty urgent.
And we managed to push everyone to finish in 91 days. And it just happened that was in August rather than July 10th. So I dedicated the entirety of my summer to an asteroid.
Yeah.
Don't do this, people. Do not be me.
Yes.
Actually, be me. I need you to be me.
Yeah. Help her so that she doesn't have to be her.
Yeah. Accurate.
Evil Mind says, rocking the Dyneema. I sure am. Dyneema is a outdoor fabric made from spectra. So it's like a super light composite material. And so, my pack for like a 5-day hike is 20 pounds. And Carla's pack, including dog food and dog stuff, is 10 pounds for the two of us. So her pack is 10 pounds, all food, water, fuel, tent, sleeping bags.
That is not
food.
4 days worth of water. You're getting more water as you go.
Oh, of course.
Okay.
Yeah. It's one thing that we have here. It's water. So you
true.
don't carry any water. You just stop and refill your water bottle at any stream you want.
Life straw for the win.
We no, you don't want to use the life straw. They're actually not that great, but you use a different machine called a Sawyer squeeze. So
okay.
Yeah, but it's just like, as you know, old man joints, hard on the back, hard on the knees. It's so great to have like a pack that you barely even feel. Okay, I forget, what do we do? What's our job?
I think we're supposed to do this podcast thing called Astronomy Cast, maybe?
Yeah, let's do that. All right. Well, while you were nerding out on a space rock, we doubled down on the Guide to Space over on our YouTube channel. And so we put out twice as many episodes a week. We did 2 instead of 1, which was an interesting experiment. And Chad's actually watching this episode right now. I think he can say we're both a little worn out. But it's been a great experiment, a lot of fun, and just sort of a way to give back to all the patrons who have been supporting us, to say, hey, you give us a lot of money and I'm going to spend that money on Chad. So thank you. And now Chad gets more work. So that's what happens. So I can't wait to hire more people and do more things. All right.
That is awesome.
All right, let's get into this week's episode.
Okay.
It is 536, right?
I haven't looked. I thought it was 538.
Let me make absolute sure. It's 537, apparently. Okay.
Okay, we were both wrong. We bracketed it quite nicely.
Yeah, it's weird, though, because my last one here in the intro says 536. So, oh, there we go. Somebody changed it. That's funny. Is that you, Susie? All right.
It's got to be.
Yeah, Susie must have changed it. That's so funny. All right. I'm ready to press record when you are.
I'm pressing record. It is using all the correct things.
Testing. Yes, I'm good. Here we go. Astronomy Cast, episode 537, The Reusable Rocket Revolution. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today, and with me, as always, Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Great. Welcome back from hiatus. Summer over. Time to get back to work.
It was too short.
Yeah.
Want more summer.
Well, of course, neither of us actually did anything that even marginally resembles vacations. I doubled the amount of Guide to Space videos that we were putting out every week, and then went and climbed a bunch of mountains.
And I have been doing a daily news stream over on Twitch, which became a daily podcast starting this week. And we mapped 10 million objects on an asteroid.
That's crazy. What an incredible accomplishment. Nate, you foolishly signed up, you and a few thousand of your friends, to map out the features of asteroid Bennu. How hard could it be? It's just a ball of rock. Turns out it's not a ball of rock. It's a loose amalgamation of gravel and has a lot of rocks. And you guys mapped that hard.
We mapped it so hard, and I think it mapped us back. I don't know.
Yeah. So now, is there like a final count of how many rocks are on the surface of that?
We're still in the process. So here's the thing. We were not expecting this much stuff. And because we had anticipated, our database is only going to be this big, we read all of our software without putting in all the needed extras you put in if you have super large data that you have to page through a bit at a time to prevent getting timeout errors. No, our software started triggering timeout errors. And we're still in the process of rewriting all the bits that need to be rewritten to deal with not medium-sized data, but medium-large-sized data. I'm not going to call this big data because nowadays there's like terabytes of databases that are being generated per day.
Yeah.
We're not there, but we are at the hundreds of megabytes per day.
But are we safe to say that it was in the millions of individual features that were identified on Bennu?
Yes.
I mean, have there been objects, like is even Mars or the moon that number of objects identified?
Not at this scale size.
Yeah.
So I don't know of any object that is consistently marked at this high a resolution.
Even Earth isn't mapped at this kind of a resolution.
Yeah.
Yeah.
Yeah. So it's kind of terrifying. It's just a rubble pile, a loosely held together rubble pile. And we now know all the boulders on the rubble pile.
Yeah. What an amazing accomplishment. Congratulations to everybody. If you're listening to this and you were dragged into this amazing accomplishment over the summer, what a wonderful thing for science. And I can't wait to see what you guys take on next. But it's just tremendous.
And what I'm really looking forward to is confirming the names of everyone who marked those areas where we will be looking to do site sample selection.
Incredible. All right, let's get on to our work. So we took a hiatus this summer, but SpaceX sure didn't with the tests of the Starhopper prototype. Today we're going to talk about the revolution in reusable rocketry and the quest to build a fully reusable two-stage rocket. All right, Pamela, so were you watching some of the live streams over the summer of the Starhopper prototype?
Yeah, I unfortunately am one of those people that kept turning it on the days they did absolutely nothing.
Yeah.
So it turned out a watch Starhopper never hops.
Oh, it's your fault.
It's my fault.
Yeah.
But when I wasn't looking,
it did hop.
And it did it in the most glorious of ways because being SpaceX, they think about things like, oh, it's the golden hour. The lighting will be perfect. We shall put our drones to take the video over here and catch it from the most artistic angle possible. So these are like visually stunning, albeit with a fuel mixture that was a little bit off. But yeah, this was just amazing.
All right. So I was able to watch the short hop test live, and then I missed the full 100+ meter one, but it just, you really feel like you're watching history get made. I mean, who knew water towers could fly, right?
Exactly. It's a whole new way to treat your farm equipment.
Yeah, exactly. Grain elevators next. All right, so let's go back and talk about why this is important. Why is this important? Why is this a thing that people are trying to do? What's wrong with the rockets from the days of yore? We used to have a Saturn V. It took us to the moon, and that was fine.
Well, it turns out it takes time and costs money to build those rockets. And every time you don't reuse it, you're requiring a whole bunch of people to build something new from scratch. And you're increasing the cost per pound that you have to spend to get that stuff into space. If you can reuse anything, each bit that you reuse means you don't have to pay for it a second time, and you don't have to wait for it to be constructed. So the dream was to get us to that, airplane kind of a future where just like Boeing doesn't usually throw out its planes every time you fly them once, and one 747 gets to get reused for decade after decade. Well, it was hoped that, maybe a rocket won't have a decade of experience flying. It'll at least get 3, 4, 5 launches before it gets recycled into the giant rocket pile wherever they put those.
And Star Trek and various science fiction from the 1950s and stuff, we saw images of rockets. They would land, they would take off again. That was the bold future. It seemed obvious that that was what would happen. And yet, for some reason, these reusable rockets never came about. They were always destroyed, every part of the rocket, except for like the little capsule that the people sat inside, was burned up in the atmosphere, left to orbit the sun forever. Why did they not go straight to those reusable rockets early on?
Well, I mean, put simply, space is hard. But early on, we simply didn't have the computational power to be able to do the fast maneuvers that are required of the rocket engines to maintain an upright flight as they come in for a landing. It's only modern computational power that allows the Falcon 9 first stage to come in and land on moving targets like barges and stationary targets like seashores. Now, with the space shuttle, it had been hoped that we'd be able to repurpose more of it than we did. The external tank is just a tank. How hard can that be? The solid rocket boosters, will those burn up? But unfortunately, even there was concerns that if we start reusing the engines too much, it's too dangerous for human life. At one point, there was plans with the Space Shuttle C program, which was never actually flown, that they'd reuse some of those components while carrying cargo that didn't include human beings. Because, well, if you accidentally blow up an AT&T satellite, that sucks for AT&T, but no lives are lost. And even that was just poo-pooed and pushed aside. It was only really with the Ansari X Prize that we saw motivation put out there of, it's time, people, we will reward you, money, go forth, try this. And it was scaled composite that was able to finally win that, although now Virgin Galactic, which has purchased scaled composite and has moved forward with the reusable space plane component, is one of the, well, laggers in the space race to get reusable to be the thing everyone's using.
Right, but the original X Prize was incredible and exciting, but the goal was fairly modest. It was about having a vehicle be able to fly to the edge of space and return, and do that twice within 2 weeks, I think. Mm-hmm. But flying to an altitude of 100 kilometers is a completely different story from going to an orbital velocity, which is, one thing is flying up high, the other is going sideways 28,000 kilometers an hour. Two different orders of magnitude.
Yeah. And this is that Kármán line that so far we've had skilled composites get past. We've seen Blue Origins get past with their new Shepherd, but only SpaceX has done reusable orbital rockets so far. And what makes these orbital launches so much more difficult is that stage that you're bringing back is reaching a significantly higher altitude, has to carry the fuel it needs to get back, and then maneuver through all the different layers of wind, all the different layers of turbulence in that atmosphere to get back to, well, pretty much its starting point. It's yo-yoing through space.
Right. So let's talk a bit about how this whole reusable rocketry path is going to work. And I think, here we are as we're recording this episode, and we've talked about SpaceX many times, but we are sort of planting a flag today, an arbitrary flag, and just talking about the history and the potential future of reusable rocketry without necessarily knowing how it's all going to work out. So, yeah. But we've seen enough just mind-bending accomplishments so far that I think we feel pretty confident that things are moving in the right direction. So, from where we are, where are we today at the state of reusable rocketry? How much of a rocket gets reused right now?
Currently, we're looking at the first stage, which is the bottommost part of the rocket that expends all of its fuel and then gets cast aside in most cases, or flown aside and flown back if you happen to be SpaceX. And we're looking at single stage rockets, starting to figure out how can we will bring back our entire thing. So this was the thing that really was like, ooh, we need to start doing a show on this, that brought this home to me. The Electron rocket is looking to go reusable. This is a little tiny rocket. They're currently getting launched out of New Zealand. They are only launching the tiniest of cargos. And since they don't have all that much extra room, the question starts to become, how do you come back safely? And they don't have it in them. Literally, they don't have the space in them to start to do the retro rockets that you see on the Blue Origin and the SpaceX rockets. So they came up with the creative idea of carrying a parachute with a special side drag, and some crazy helicopter pilot is going to be tasked with catching these things as they fall out of the sky.
Well, they're not the only one who are considering this approach. Of course, United Launch Alliance, they have the Vulcan rocket, which is going to be their next generation rocket designed to really compete with SpaceX. And it's not going to be fully reusable in the way that the first stage of the Falcon 9 is. It's going to have these strap-on rocket engines that will peel away from the first stage, and they will drift back to Earth on parachutes and get caught by helicopters, because according to United Launch Alliance, really it's the engines and that whole part of it is the most complicated and expensive. They're going to be using Blue Origin BE-4 engines, like Blue Origin's New Glenn rocket. So it's a sort of a there are a bunch of different strategies that are going into this, some of which are going to be more cost effective than others. But SpaceX has already demonstrated full reusability of the first stage, what is got to be the most, it feels like it's the most elegant way, but they're already pushing forward with the Starship. So let's talk about what the Starship is going to accomplish.
I have got to go get a cough drop before we continue. I will return. I'm so sorry. I'm leaving my audio running.
Yeah, no problem. 1419, Susie, if you want to just write that down for when the big hack comes in. Pun intended. Yeah, Pamela we call this con crud. When you go to a convention and interact with a whole bunch of other people, shake a lot of hands, you always come back sick. Every time. Especially Pamela. So... Oh, that's cool. So Kyle Carmichael is saying that catching a parachuting rocket is nothing new. They were catching Corona capsules back in the 1960s. But they weren't boosters, right? They were just... Now I'm having trouble breathing. They were just capsules, not actual rocket boosters. Like a rocket booster is an enormous machine that weighs many tons. And to catch that as it's plummeting back to Earth, you got to think about the dynamics and the danger of doing that. And if you mess up, then your rocket crashes into the ocean, and better luck next time. So at this point now, like, I don't know about you, Pamela, but from my position, like, everything else just seems ridiculous compared to what SpaceX is doing with them landing under their own booster. Like, everyone thought there were a bunch of different ideas, right? What if they use balloons? What if they use parachutes? What if they, I don't know, if they catch them with an airplane or something, right? But now it's just clear that this just works. And every model. And, I'm not sure when you want to pick this back up, Susie.
No, but, so Susie, you're going to have a fun time editing this. We are so sorry.
Yeah. I was talking with Anton Petrov from What Da Math. He's a YouTuber, and he was saying that there are literally now dozens, if not hundreds, of rocket companies in China that are pushing forward the whole concept of reusable rocketry. So this is the way. And not only reusing but I asked you about Starship. So can you, like, if we, put that arbitrary flag in the ground and say, okay, here we are, SpaceX has nailed first stage boosters. The Falcon Heavy lets you strap 3 of those first stage boosters together, reusing a big chunk of your rocket. Starship takes it to the next level. So what's the plan there?
So Starship is a oh man, I'm going to start this over. I was fine all day until now. So Starship really takes it to a whole new level. They have all sorts of engines, fuel compartments, and everything else that allows them to carry with them everything they need to land on, for instance, the moon, vertically take off from the moon, hop back to Earth, and vertically land here again. Now, we're only testing this one stage at a time, one silo at a time is the way it looks. But these rockets are essentially giant silver tubes of fuel with fully steerable engines. And their ability to nail the fully steerable is really where they shine. They have at the top of each stage these little thrusters that keep them upright, and at the bottom they can steer their bottom engines as well. And through all of this, they can prevent themselves from spinning, they can prevent themselves from tilting, and they do this in such a fuel efficient way that they can go there and come back again.
Yeah.
That's amazing.
Right. And so at this point, SpaceX still, they reuse their first stage rocket for a significant cost savings, but they still have to ditch their upper stage, the kick stage.
Catch their fairing.
And they're now catching their fairings. But the magic of the Starship will be, as you said, that they will be able to reuse that upper stage of the rocket fully.
I do want to go back to the fairings for a moment, though, because this is the most video game-like thing I have ever seen in spacecraft development. They have a speedboat.
Two of them.
It's 2 of them.
Yeah.
The one that successfully caught used to be called Mr. Steven.
Yeah.
Now called Miss Tree.
Yeah.
The first time out after the rename, they zoomed it around in the ocean, caught one of the fairings, and this is the kind of thing where you kind of expect the Benny Hill music to be playing as they're like zip, 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 catch it. This is just ludicrous here.
Well, as Elon Musk said, the fairings are worth $6 million. It's like watching a pallet of money fall back to Earth and not try to catch it. And so now they've caught 2 at the time they were recording again. They've caught 2 of these fairings, 2 halves of the fairing, but not at the same time. And now that they've starting to nail the one catch, they've got the second boat. And so the plan is they're going to catch both fairings and reuse them. So they're getting closer and closer to that fully reusable future. But back to the Starship.
Okay, fine.
Yeah. So what are I guess the question is, like, in your mind, I'm sure people are like, well, fine, you reuse the first stage, then propulsively lands on its launch pad or lands on a barge in the ocean. Why is the top stage so much more complicated?
Well, it becomes a weight issue. You want to carry as little as with you as possible. And this is why when we send most things back to Earth, we only bring the capsule. In general, when we send things to outer space, we are, to use the Soyuz as one of my favorite examples, they have a lower skirted area attached to the Soyuz capsule, which is where they have things like stowage. They stick their space toilet there. And before they bring any of those capsules back down to Earth, they discard all of that. The number of space toilets destroyed by the Russians is truly a thing to behold. And the reason that they're doing this over and over and over is that's extra weight that they have to figure out how to steer, how to maneuver, how to shield, and to be able to deal with the heat of reentry, the needed maneuvers so that you don't burn up, and then the braking, which is currently done with parachutes. You don't want to have that much stuff with you. And by landing a powered landing, not even the shuttle had a powered landing.
Yeah.
The shuttle was a glider.
Yeah.
Have a powered landing, you have to bring all the fuel, all the added weight for the engines, everything with you, which is added weight going up. And then you need to have it coming back, or else you run into the, oh shoot, we ran out of fuel before we actually got to the ground, and you crash rather abruptly into the surface. And that's not pleasant for anyone involved. And the other thing about this is it means you just don't have to reconfigure. So currently you launch one way, you enjoy your space toilet, you reconfigure things as needed, and then you come back down in that new configuration. This avoids all of that. There's no back and forth, up and down, moving where you're hanging out. You have everything the entire time.
The plan is for when the full stack is put together, right? The whole thing will launch with the first stage, which they're calling the Super Heavy, and then the second stage, which they're calling the Starship on top. The whole thing will launch. The first stage will detach once it's out of fuel, return to the landing pad, to the launch pad for refueling. It should land precisely where it needs to be to take off again. The upper stage, the Starship, will fly into orbit, do whatever it's got to do, as you said, go to the moon, orbit, take people, to the space station, and then it will need to come back through the atmosphere, which is, we saw with horrible results how dangerous the atmosphere is with the Columbia disaster, land beside the launch pad, and then they'll use a crane, stack it back up, refuel the top, and away they'll go again.
And I think we need to leave room for them to say, hey, we're trying to get to this particular object that requires a whole lot of extra fuel to take off, so we're going to land on a barge in the ocean. But the thing is, they know how to do that. The real motivation to land on land is to avoid salt. Seawater is highly corrosive. Yeah. When they land on barges, they get extra corrosion from the splash, the mist, the fog, all of that. Landing on land is just, less corrosive.
So what will be if they pull this off, what will this save? How will this change things?
Oh, so I don't even know where to start.
Price, cost?
Yeah, price is really the big deal. Going to space right now, well, first of all, space is hard, but space is also expensive, which means that there's lots of experiments we can't do just because it's too expensive. There's lots of materials that we can't develop in gravity that we know we can develop in the microgravity of space, but it's too expensive to get our chemicals to space, do the manufacturing there, and then bring things back. So from manufacturing to research to tourism, there's always going to be rich people wanting to go to space. This starts to make all those things more accessible. Now, it's unlikely to enter us into that new TWA age of go where you want, when you want, on vacation, if you're a normal everyday person. But it does start to get us to, the more people we get in orbit, it's also going to have a societal effect. We know about the overview effect from astronauts, where as they look down on Earth, they realize, oh wow, our world is so tiny, so fragile, so small.
Yeah.
And by getting the people who are in power around the world and who control resources around the world to see our world with this new perspective, there's also going to be societal effects that we can't even begin to imagine. Maybe the first two we need to send up are actually Bezos and Musk.
Right. Well, I think both of them would love to take a flight on their rockets once they're safe. But I mean, I've heard people say that it could bring down the price of launches by a factor of 10 to a factor of 100. So right now, traditional rockets are on the order of about $10,000 per pound to launch into space. a trip on a Falcon 9 brings that price down into the couple of $1,000s, a little cheaper if you go with a Falcon Heavy launch. It's thought that the Starship will bring the price down onto the order of a couple of $100 per kilogram, maybe even below $100 per kilogram. And the hilarious thing about this is, in fact, that price is cheaper than people used to estimate for space elevators.
And since space elevators are really complex to build, and we don't yet know how to do this, yay for reusable rockets.
Yeah.
And one of the big factors that makes it so hard to figure out just how low the price will go is we have Chinese companies like Link Space that have already managed to do 3 successful hops of the same rocket, and they haven't made suborbit or even orbit yet. But the more companies we have doing this, the more competition there is, and the more innovation is going to be driven. And that also has the potential to lower costs. Just figuring out how to effectively get the manufacturing of the rockets. So it's not just the cost of a given rocket, it's the cost of the whole assembly line that makes that rocket. So there's going to be price costs that come in getting more efficient at building the rockets, price cuts that come from getting more efficient at reusing the rockets. And well, we don't know just what the lower limit on price just will turn out to be.
And I know a lot of people, when they're starting to hear about these rockets launching, more launches, cheaper launches, what about the environment? There's a bit of good news though with both what SpaceX is doing and with what Blue Origin is doing. They're doing methane rockets. So methane is a chemical that is a potent greenhouse gas, but in fact you can create it right out of the atmosphere. So you use solar energy. You can turn water and carbon dioxide into methane. So in theory,
and methane breaks down under ultraviolet light.
Right, but in theory, these rockets will be carbon neutral. They will be generating their rocket fuel right at the launch pad, pulling it right out of the atmosphere, and then turning it into rocket fuel. And in fact, I wish that airplanes would do that, because in theory, airplanes can use methane as a fuel as well. So it would be great to see that whole technology push forward to the point that all air travel is carbon neutral.
This is one of those things where we keep learning we don't fully understand our own atmosphere in always the negative direction. And since these rockets do relocate where atoms are at different heights in our atmosphere, I'm going to be more cautious on this one.
Yes.
But using methane is definitely the direction to be going. Early models looking at standard LOX systems actually had some pretty devastating impacts on our atmosphere, because they were putting things back at elevations in the atmosphere that were very bad for the greenhouse effect. So hopefully we're getting better over time. Hopefully we're getting better at modeling over time. And the other thing is that by getting more fuel efficient on the rockets, by being able to launch heavier payloads with lower impact, well, it's essentially the Tesla of outer space. Carry more, impact less.
So let's just, before we wrap up this, let's talk just a bit about what people are going to see unfold over the next few months and years, because we really are at a bit of a turning point for this whole process right now. So as we mentioned, we've watched the Starhopper, which was the first prototype, which was really just a little water tower with one Raptor engine underneath, and it did 2 hops, one very short, one that was really cool. What comes next? What's their plan?
What's particularly cool with Starhopper is they now have 2 sites, one in Florida and one in Texas, and they're essentially racing against each other, doing incremental innovation where they develop something new, test it. If it works, they share it with the other folks. And this constant innovation, try and test. we don't know how fast you can innovate when you're not worried about failure along the way, and accept that failure is part of developing new ideas. This is radically different from what we've seen from things like the ULA consortium. I am kind of betting that we're going to start seeing some of the old aerospace getting their contracts canceled,
Yeah.
as SpaceX basically says, thump, here it is, and is able to launch heavier and heavier things at lower and lower costs. Now, this unfortunately is going to have impacts on all the spacecraft that are currently under development that we're planning to launch on these already paid for ULA rockets. So I think there's going to be a period of epic confusion as the landscape radically changes. I think that we're going to start to see basically shaming of companies that don't reuse.
Yeah.
The way Electron was like, well, we're going to be reusable now, was awesome, but definitely had an air of, well, everyone else is doing it. We're going to do what everyone else is doing.
It out. Yeah.
And that public shaming of non-reusability, I think, is going to be the most amusing part as a spectator.
So the next big event, I think we're going to see the Mark. So they've got these, you mentioned these two facilities. They've got their Mark 1 Starhoppers, which are pretty much full-scale mock-ups of the first of the Starship. They're a little smaller, but they're going to launch in late September, like just a couple of weeks is the plan to start, some into the multi-kilometer altitude. And the thinking is that they will actually launch orbital by 2020 or even 2021.
And while it isn't the advances in reusability, Blue Origin is looking with their New Shepard to launch human beings before the end of this year. And we're still waiting to see if the Falcon is going to be able to launch with human beings this year. And it's not called off yet.
Yeah. Yeah, they had that explosion over the summer, so that was a bit of a setback. But yeah, the plan, they did a test fire of the SpaceX, the Crew Dragon, successfully just last week. So I think they're moving forward to being able to actually launch human beings. So this is definitely going to be a topic that we will come back to. But and it's obviously been a theme in many of our episodes as we've been going along. But we just wanted to bring it back and sort of see where we are along that pathway. And I'm sure we'll be talking about it again if Starship does truly launch with the full stack. Pamela, go ahead.
And I just want to acknowledge that while we've focused on SpaceX, it's not just SpaceX. There are multiple Chinese companies. I mentioned one. Avatar is being put together by India, who also has their reusable launch vehicle TDP program. This is a multinational time of everyone getting on the reusability bandwagon. And here's to hoping that everyone starts live streaming it.
Yes, please.
Stuff is just fun to watch.
It's so exciting. Yeah, absolutely. Before we go, Pamela, do you have any patrons to thank?
I do. I moved that window. Sorry, Susie. Sorry. So we are here by the grace of you. Astronomy Cast is produced by Susie Murph, who does more than just edit together the sound. She also herds Fraser, gets everything posted. We're working on planning trips. We just got back from 4th of July weekend going out to Joshua Tree. All this myriad of random stuff. Well, you let us pay her, which in turn lets her kid go to college. So you are making the world a little bit better and a little bit more educated every time you support us on Patreon. And I want us to thank just a set of those people. So I'm going to thank Jordan Young, Burry Gowan, Ramji Amanthu, Andrew Polstra, David Trogg. Sorry.
On crud.
Brian Cagle, the giant nothing, and Laura Kettleson. I'm going to stop now and go get another cough drop while you close out the show.
So thank you, Pamela, and thank you, everyone, and we'll see you all next week. Oh. All right, let me save. I know why we skipped an episode, because we recorded an episode live at Joshua Tree. Doy. Okay, I'll be all right. Just exporting. And then we will get on to your questions. So a couple of people were mentioning in the chat, in about half an hour, India is going to make their attempt at landing on the moon. So I don't know whether they're going to do a live stream. Does anybody know a link to a live stream? But they're going to attempt to bring their Vikram lander down to the surface of the moon at the South Pole. So let's wish them luck. In fact,
Sorry about that. The show must go on, but
yeah,
my lungs didn't agree with that.
No kidding. So did you know of a place where we can watch the Indian landing unfold in live? There you go. Chad's watching right now. That's probably, by the way, Chad, that'll probably be our next episode after we finish our Lagrangian points. So we'll probably do next week. We'll do our episode on the Chandrayaan 2.
Normally we cover it live over on CosmoQuest, but I'm here and Annie had to take her cat to the vet.
Oh, right.
So in general, anytime there is a launch that is being live streamed and it's not 4 a.m. on the East Coast, we'll be bringing it to you live over on twitch.tv/CosmoQuestX.
It was, well, I'm going to switch over to that. I'm going to be watching the opening season of Path of Exile in one window and the landing of India's lander at the same time. And it's going to be a good day. I'm really excited for this landing. They got their own lander, they got their own rover, and I mean, a lot of people don't know, but it was originally the Indian mission that really gave us confirmation that there's water on the moon.
Yeah. And what an amazing new age that we're in. Back April 19th, Beresheet didn't have a soft landing.
Right.
But it populated the moon with tardigrades.
Yes.
Now we have China on the far side of the moon exploring, which requires having a comm satellite set up. And India is taking the same idea. They have their own comms set up, and now they're landing in the South Pole Aitken Basin.
Yeah. Stunning. We've got about 6 minutes to tackle any questions that anybody has, but I think I
have a new cough drop, so I'll be better now.
Are you okay? Yeah, 6 minutes. It should last us for 6 minutes. But if anybody has any questions, Dustin King asked, could the Spaceship 2 approach of piggybacking on an airplane eventually lead to orbital flights from regular airports?
It doesn't look like it. The amount of fuel that you have to have on board to get from the typical flying altitude of the lift airplanes, you're looking at 30 to 40,000 feet. The amount of weight those planes can carry isn't sufficient to then get you up to that. So the Karen line, which is the one that they're crossing, that's 300,000 feet, and that's only 100 kilometers up. You're looking at wanting to get to more like 500 kilometers up, and that's going to require a lot more fuel. So it's the tyranny of the rocket equation.
Right. There's a couple of attempts. There's the Stratolauncher, which is the biggest airplane in the world, and they're starting to do some tests, and it's going to carry rockets to high altitude, as high velocity as it can go, and then drop them off, and so act like the first stage of the rocket. And then Virgin Orbit is going to be doing this as well. Same sort of idea. You take a Boeing 747, you put a rocket under its wing, and in fact, there's a launch vehicle called the Pegasus, and that's what this does. There's another launch vehicle called the Taurus, and both of those are air launched by modified 747 aircraft. So this has been done, But it's just so many moving parts, right? You have an airplane. The airplane, you have to strap the rocket to the underside of it. The airplane takes off, flies to a certain high velocity, drops the rocket. Rocket has to be able to launch to space without it, hitting the airplane at all. It's just so simple.
Well, and you don't, with the airplane launch, get the added help of the Earth's rotation. You don't get well, you're much more size limited. So you're looking at a single person, two people, something much smaller if you're going to try and get to orbit, even suborbital with just a handful of people off a scaled composite. Suborbital is about as good as they're looking to get with their White Knight 2 and I forgot the name of their second launch system.
Spaceship 2?
Yes, that would be the word I lost.
Did you hear that Elon Musk wants to build an 18-meter version of Starship, twice as big? That's what comes next. You hadn't heard that? Oh, yeah, no. So he mentioned in a tweet, someone was like, what comes next? And he said, oh, we're going to build one that's twice as big. It's going to have an 18-meter diameter, and it's probably going to be twice as tall as the original Starship. And somebody did the math, it was like 150 engines. Raptor engines. But okay, right? Like, why not? Sure. I mean, here we are. We just watched a water tower fly. We watched 3 Falcon boosters bolted together land. So at this point, we just wait for these things to happen or not happen. We didn't even mention the fact that they've switched the Starship to stainless steel, that it's going to be using it sweats fuel, although maybe not now. So anyway, it's madness. It's madness. What a time. What a time to be alive.
It's pretty awesome.
Yeah.
And also insane simultaneously. We need more comic books about this stuff. This is like the fuel for comic books. I want like your evil enemy to be building their spacecraft out in like the Midwest farm company, and everyone just thinks it's new silos going up, and really it's a fleet of rockets being prepared to launch and take over the world.
Or to escape an impending disaster.
Well, that too. Yeah. That starts to get you into more not Starship Troopers. It was Starship Troopers. Was the 1980s anime where they were like all flying away from the Earth in boats that got pulled out of the planet.
Are you talking about Star Blazers?
That's what I meant. Yes, that is what I meant. I just took a lot of cough medicine. I'm sorry.
With the spaceship Yamamoto.
Yeah.
I loved that show as a kid.
It did not hold up well.
Does not hold up. No, I was like, so sad. Yeah, it blew my mind that such a thing was on television when I was a teenager. I was, maybe 12 or so, and it was just like, this is so great.
Yeah.
So much better than any terrible animation that we have. And so when my son and my daughter were little, I was like, oh, let's watch a bunch of the anime that I used to watch as a kid. And they were just like, nope, no thanks.
Yeah, it did not hold up.
No.
It was fabulous in its time, though.
Yeah, they've come back around a bit. They've got their own anime that they like to watch, but yeah, it's pretty funny how like ever mentioned, my kids just can't stand Star Wars. They don't like it, or Star Trek. Nope, not interested. Like, I tried. Of course I tried. Nope, no interest. They would much rather Chloe loved, I'm trying to think what Chloe loved, Avatar, The Last Airbender, right?
Avatar, the cartoon, the live
cartoons,
action movie is
no, not the movie, no, and then The Legend of Korra. So that's the kind of stuff that Chloe's really into. Okay. And Logan really enjoyed like Futurama, Rick and Morty. Yeah. So, but yeah, it's so funny how you can't make your kids love the things that you loved as a kid. It's just they are their own people. But then weirdly they listen to my music, so kids.
80s is in style, like even
in 90s,
people thought that pop-up collars were dumb.
Yeah, But it's weird that, yeah, I mean, again, my kids, my kids are listening to, it's as if I was walking into a nightclub in 1992 and just listening to their music. Like, is something new happening? Come on. All right. We've complained enough about kids these days. Right. Paranor's noting, my daughter loved Doctor Who. So that one stuck. I was able to show, show Doctor Who, and she loved that. So, okay, and my son loves Letterkenny, which is hilarious. If you haven't seen that, you should watch that. It's a Canadian show, but I think it's on Hulu, and it's so funny. Letterkenny.
Okay.
All right. Let's wrap things up. So thanks everyone for watching us. Pamela, great to see you again. Great to hang out. We haven't hung out since Joshua Tree.
Yeah.
And now it's time for just like show after show after show. Welcome to season 14. Madness. All right. We'll see you all next week.
See y'all later. Bye-bye.